So before start the actual project explanation, I request you please subscribe my channel. So you can see on the screen up till now I have uploaded more than 66 video on Raspberry Pi. The Raspberry Pi with IoT, that is all this video. Then also IoT with Arduino, all this video are 26. And recently we started the new series on the PIC microcontroller. Before that I also cover the project on the Python web application. So if you want to learn Python, IoT, Raspberry Pi, Arduino, PIC from the scratch and from freely, then please subscribe my channel, please support me. And the most important part is whatever the code I have explained, whatever the project I have created on this YouTube channel, all these projects are freely available. You no need to pay anything for this project. So just if only point is you should watch complete video and you should follow my process. So if you want to learn something from the scratch and freely, then support me and please subscribe my channel and please click on like button. Okay, today's topic is that in 2 years back or 1 year back I have uploaded the video that is Proteus simulation of driver sleep detection video on Raspberry Pi. Also there is another video like with Arduino, that is driver sleep detection. But in both the video I haven't explained the program. So I got one request from my subscriber, sir please explain the program in English language whatever you have used in that video. So in this today's video I only explain the whatever the program, Python program that is used to detect the sleeping condition in Raspberry Pi project also and in Arduino project also. That program to detect the sleeping condition through the Python, that program I will explain today. So if you want to learn how the Python work to detect the sleep status of the driver of or any human, then please watch this video, you will get idea. If you want to see the what is the practical output of this project, then please watch my this video, driver sleep detection video using Raspberry Pi or driver sleep detection video using Arduino. Both video link I will provide in the description, so that if you want to implement that project, then you can follow that video and you can implement the project. Today's goal is to explain the Python program that I use to detect the driver sleep or not. So let's start the program. Okay, first line from the program is input CV2. So basically it is image processing library we are using, then NumPy library we are using, then dlib library we are using, then face utility, that is immutales library we are using, serial library we are using. So whatever the library which are required for this project, that I have defined here. So from this library we will use some function that I will explain in later. Next is serial.serial comp19600. So basically this serial library, this is a serial library, and here in at the line of 11, you can see at the line of 11 we are declaring one object. So whatever the function if you want to use from this serial library, we will use from this yes object. So from that yes object we will use that serial library. So why this serial library is used, that is the main part. So basically when you say the Proteus simulation of this video, there are two programs parallelly working. One program is nothing but this Python program, and second program nothing but you can see at the background there is some circuit diagram which are the Proteus program. So this Python program basically detects the sleep condition or not, and this Proteus program will display on the LCD whether sleep is detected, buzzer will turn on. So all the things will be done by this Raspberry Pi program. So to send the data from this Python program to the Raspberry Pi program, we will use one bridge, and that bridge is nothing but the serial communication. So in this you can see here, you can see there is a uh, RS this serial terminal model, that is comp pin. So comp is nothing but to transfer the data from this Python program to the Proteus program, and to transfer the data from Python to Proteus program we will use serial communication. So that we have to define the baud rate and which virtual comp pin we are using. So we are creating the comping virtually. So how to create that comping virtually, that I told in this video. So please watch that video if you don't know the virtual comping. So basically virtual comping we are using comp1, and 9600 is nothing but the baud rate. So with this functionality we will transfer the data, that is sleep detector or not, from the Python program to the our Proteus program. So for that we use here serial communication. Then after that you can see there is a initial camera. So whatever the camera, let's say if you are using the laptop camera, or if you are using the USB camera, so that camera object we have to define. So to define that object, we will use this line. So here you can see there is a 0 or 1. So if you give 0 here, that means you are using the laptop inbuilt camera, and if you are using the 1 here, then that means you are using the serial USB camera that I use in my project. So whatever the camera you want to use, you can define that object here and change the setting like this. Then there is a front face detector. There is delay library, and from the delay library there is a function front face detector. So whenever the camera capture the image, we have to detect the face, so that this line is used. And with this function there is one object, you can see this is the object. From that object we will use some function to detect the front face of the human. Same, there is a shape editor, delay shape predictor. So basically I will tell you the logic something behind this code, so that you will get idea what we will discuss afterward. So you can see we have used the shape predictor 68 landmark. This program already given in my this video, or any all this video. If you want that program, you can download from that video description, and in that description you will find there is a one file, this shape predictor 68 landmark dot that file. So this file is basically used to predict the landmark. So basically you can see, when I say there is landmark, so what is the landmark, I will just show you. So this is our face, and each face you can see there are these types of landmark. Eyes having some landmark, then nose having some landmark, then external face edges having some landmark, then eyebrow having some landmark. So to detect, to predict that landmark, we have to use this line, shape predictor landmark. So through that landmark we will through that landmark we will see whether our eyes is blinking or not, all the things. So but the first line is we have to detect that landmark. So to detect that landmark we will use this line. Some variable sleep, drowsy, active. So those are some variable which is used to detect whether sleep is sleeping state, active state, something, then status, then color. So all these are the some variable. We will use this variable later, and what is important, that also we will see later. So directly I will jump here, 55 line number while true. So first what happened, cap read. So basically you can see cap is nothing but object. So we already defined that object here. You can see here cap. So this is the object. So what this object is, this object, it is used to access the functionality of our camera. So here we are using cap read. So read the whatever the image from the live image from the camera, that reading from this cap read function, and that image store into this frame. Then after that cv2 is the library which convert our image into the gray form. So that gray from color image to gray form, it is converted here. Then honk face detector. So basically this is another object. You can see this declare here, honk face detector. So as I already told you, dlib get face detector, it is a function, or it is the very we can say library, and it is the object of that library. Through that object we can detect the face. So here you can see honk face detector, whatever the image, gray image we converted from our camera, we pass to the honk face detector, and that gray image convert that image, and gives us the different types of faces available in the image. So at the line of 68 we are getting the faces because of that honk face detector library. Then we are finding the faces in the face, all this line. Then after that we have to draw the rectangular uh, in the edge of the face. So you can see on the here I can show you just small example what is rectangle. So you can see this is the rectangle that we have to draw. So to draw that rectangle we will use this line. Then after that landmark. So basically this predictor is nothing but the object. You can see here object of shape predictor library. So from the predictor you can see we are passing our gray image and face. So what here it will do, it will predict whatever the landmark here, all the landmarks are available. See, those are the landmarks from the face. So this predictor line, what will it will do, it will calculate all the landmark and store into the landmark variable. Then after that we have to take all this landmark into the array. So to convert that landmark and store into the array, we will use this line. So all this landmark now we will find into this landmark array. So up till now what we have done, I will tell you from this image. First we capture the image, live image from the we can say of the person. Then after that we draw the square box for that face. then we predict the landmark from that predictor, and then we got this all this landmark one by one, and all this landmark we are stored into this landmark variable as a array. Then after that you can see there is a blink function. So blink function, what exactly it will do, I will tell you some basic logic. So what we are going to do now, whatever the eyes image landmark, we will only focus on that landmark. So we will calculate the distance between the short landmark. Short landmark means this 38, 42, 39, 41, then 44, 48, then 45, 47. So we will calculate the distance between these two landmark, and then we are doing some formula and again dividing the landmark distance between 37, 40 and 28 and 46, 43 to 46. So basically we are dividing our short landmark with the high landmark, and after that ratio we are predicting whether our eyes is blinking or not. So this is the just algorithm how the eye blinking condition is calculated. So up till now we got the landmark here. Now we have to calculate the distance between that landmark. So how to calculate distance between landmark, we will pass to this function, blink function. So this function will be called. Now here you can see in the blink function we have the 6 variable. What that 6 variable gives idea, this 6 variable nothing but the 6 landmark of one single eyes. So each eye is having 6 landmark, this eye is having 6 landmark. So we will calculate the distance first this eyes, then this eyes. So first we will pass AF nothing but you can see in the array, this is first line, you can focus on this first line, blink landmark 36. So array start from the 0 index as we know, so we have to give the +1 here to find the actual landmark. So here you can see 36, we are given here 36, so 36 nothing but the +1 37, so 37 nothing but the this landmark 37, then landmark 38, 38 nothing but the 37 nothing but the 38 +1, so 38 nothing but the this one. So all this landmark we are passing into this line, so you can see this line. So this line will go here, and there here you can see compute function. So basically this compute function what it will do, it will take the two landmark and it will calculate the distance between the two landmark. So first we will calculate the distance between BD, then we calculate the distance between CA, then we adding the distance BD and CA, and then that is up. So nothing but distance between 38 42 plus distance between 38 49, and then addition of that distance, that nothing but the up. Then down means, then next line is down, down means AF nothing but you can see first and last landmark, first and last landmark. If you see here, first is nothing but the 36, last is nothing but the 39, that is 37 plus 1 and 40. So 37 nothing but this one and 40 nothing but this one. So calculate distance between 37 and 40 first. So here compute will calculate distance between the long landmark and it is nothing but the down, and ratio is nothing but the up divided by 2 into down. So this is the ratio. So from that ratio we are calculating whether our eye blink or not. So if the ratio is greater than 0.5 or greater than 1, that nothing but the eyes are open. If the ratio is less than 0.5 or less than 1, that nothing but the eyes is blink and we have to return 0. So from this blink function we are returning either 2, either 1 or either 0. 2 means eyes is open, 1 means eyes is open, and 0 means eyes is closed. So this ratio you can change by yourself, is depend upon your light condition, all the thing. So 0.25 work better for me, so I put here 0.25. If some error given in the code at your end, then you can change this ratio. It's nothing but just simple ratio. So main logic we explain up till now, how to calculate the landmark, how to calculate the distance between landmark, and how to check whether eyes is open or closed. Then you can see we first calculate the left eyes ratio, then right eyes ratio. Then we are checking here, left eyes ratio is equal to 0 or right eye ratio is equal to 0. If any one of eyes ratio is equal to 0, that means it is sleepy condition. And then you can see sleep is greater than 6. So why is greater than 6 here? Because let's say if you blink eyes like this just for 1 second, and this image capture for 1 second, then it will give you status like eyes is closed, but we have to continuously monitor ticks till 6 frame. So once I close my eyes until 6 seconds, you can say, then only it will should detect the driver is sleeping. That's why here is greater than 6. That is the total number of seconds waiting for to check eyes, how much time eyes is closed or eyes is open. So that's why its sleeps is greater than 6. So once is we got sleep is greater than 6, then we have to send the yes right. Now once the eyes are open, eyes are closed, we have to pass the status to our Raspberry Pi or Arduino from the Python to Proteus. So how to pass yes right. So yes is nothing but, you can say, we have the serial object yes. So yes right nothing but we are passing a variable to the Raspberry Pi. So once the Raspberry Pi got a variable, that means sleeping state. If the Raspberry Pi got the a variable line, that means the sleeping state, and if the Raspberry Pi got the b variable from here, that is nothing but the active state. So just to pass the variable like this, and status is nothing but our sleeping variable, drowsy and active. So all these are the status. So you can see these are some repeat line. You can see all these are the repeat line, only we are passing the status to Raspberry Pi. Then after that you can see there is a cv2.put. So whatever the status we are got from the our algorithm, we have to put on our screen like this. Here you can see sleeping something name is here. So like this, so to put that status we are using this line. Then to predict the landmark, so if you want to show the landmark like this, you can see like this on your image, then you can use this line just to show the landmarks. And we are showing the image, then whatever the result we are showing like this. So these are the simple logic behind this code. I hope now you understand the code, and I hope the subscriber who requests me to explain this code, I fulfill his request. So if you like my content, please click on like button, please support me, please subscribe my channel. Thank you for watching this video.